So we're going to talk about solving quadratic word problems again. Only the last 2 days it's been working with the vertical motion model. Today we're going to actually talk about rectangles and dimensions of rectangles. And the coolest thing ever is that we're using the concept of parabolas to actually help us find the dimensions of rectangles. To me that's like weird, but it works. It's amazing. And you're going to see what I mean very soon. So our first problem, just go ahead and write it up as I write it. The first problem is, in fact, we might probably only do one of them because it's going to be number 1 on the homework. A rectangle's length is 13 meters more than 3 times its width. The area is 10 square meters. What is, whoops. How about just say find the dimensions? Find the dimensions. You know what I mean by dimensions?
Yeah.
Length and width, right? Okay. So the key is, first of all, you always draw, when you realize it's going to be a rectangle, always draw the rectangle, right? So here's my rectangle. And I've got to figure out what my sides are. What do I know about my sides? It says a rectangle's length is 13 meters more than 3 times its width. Would you guys agree with me that the foundational thing is the width? The length is based on whatever the width is, right? It's
Yeah.
three more than, what is it? 13 meters more than 3 times the width. So I'm going to make the width W or X. What do you want? X or W?
X.
All right. So my width is X. Now how would I write my length? The length is 13 meters more than 3 times the width. Remember how to do these? 13 meters more than 3 times the width. How?
13, 13 plus 3, or would it be 13?
Almost. I mean, basically that's true, except that when you see 13 meters more than, when you see that word more than, that's plus 13. It's not 13 plus, it's plus 13. So it goes off to the right. So you kind of skip that for a second and you do this. 3 times the width. What's 3 times the width?
3x.
3x. Now we go back and we add the more than, 13 more than. Does that make sense?
Mm-hmm.
Because that's just how you do it. So now, so does everybody understand how I got that?
Yeah.
Okay. Now, what's the formula for the area of a rectangle?
Length times width.
Length times width, right? So we've got this times this, right? So I could say the area is x times 3x plus 13. You guys agree with me?
Yeah.
Now, did I tell you what the area was in this problem?
No.
The area is
10 square.
10. Oh, wow. So really, the area is 10. I like to put my 10 over here. So I'm going to say the area is this, but this is 10. Does it make sense?
Mm-hmm.
Yeah. I'm just saying the area is 10, right? So now I don't need this A equals anymore. I'm just going to move it off to the side. There's my equation. Now I have to do something with this. I can't say if this times this equals 10, then either this equals 10 or this equals 10. That only works with that concept of if this equals 0, right? Remember that?
Yeah.
So the whole goal on these is to make it set it equal to 0. But in order to do that, I've got to get rid of the parentheses. I've got to multiply this out by distributing the x, and then I can subtract the 10. Okay, does that make sense?
Yeah.
It's just getting it into a normal quadratic equation that we're trying to do. So x times 3x is 3x squared, plus x times 13 is 13x, okay, equals 10. Now, it's got to equal 0. That's the goal. It's got to equal 0, so we can do that little trick. So what do? Subtract 10, right? Subtract 10, subtract 10. So I have 3x squared plus 13x minus 10 is equal to 0. Everybody understand how I got it so far? What I've been doing? It's really easy.
And then would you subtract 13x on both sides?
No, now that I have it equal to 0, then I'm ready to look at what I have that's equal to 0. Right? What is it? So, like, it's got to be under the table, right? You can't if it's going to be a... Okay, so what do? Is this a quadratic trinomial that I could possibly factor? Right? Ax squared plus bx plus c. It is, right? But it's got a is what? A is 3. So it's not that easy one where it's...
Oh, you could do Gary's.
Yeah, I could do Gary's terrific trick. And what is that again? It's a times c,
8 times C.
which is 3 times negative 10 is negative 30. I need factors of negative 30 that add
Or
to
negative 10 and negative
13. Wait, say it again?
3. Negative 10 and negative 3.
But it's got to be negative 30. So what would I?
Oh.
What?
One's negative.
Which one?
It'll be negative 3 and 10.
Well, wait. Negative 3 and 10. Let's see what that gives us. That gives me 10 minus 3 is 7. That would give me a 7 here. Right? And if it was
15 and 2.
15 and 2. There we go. Which one's negative?
Negative 2.
Negative 2. All right, so now I'm going to replace this with 15x minus 2x. You guys remember this now?
Yeah.
Right? Makes sense? So we've got 3x squared plus 15x minus 2x minus 10 equals 0. And now I factor by grouping, right? So what goes into both of these?
So 5 x.
3.
Okay, 3x, and then x plus 5, right?
Oh, yeah.
Minus 2, and remember that minus, remember when minus is joining the groups, remember that? It's going to change this as soon as so it's going to be x plus 5, right? Equals 0. So our final thing is we've got 3x minus 2 times x plus 5 equals 0. All right, now if a times b equals 0, then either a equals 0 or b equals 0. So I'm going to do that right here. So either 3x minus 2 equals 0, or x plus 5 equals 0. Now, if I subtract 5, it would be x is equal to negative 5, right? If I add 2, I've got 3x is equal to 2. Divide by 3, x is equal to 2/3. Right? I'm dividing by 3. So x is equal to 2/3. So I have these two answers. Which one would it have to be?
2/3.
2/3. Why?
It can't be negative. Because it can't be
It can't be negative. You can't have a negative distance in your side, right? Because the length of a side of a rectangle is a distance. A distance always is positive, right? So it's not going to be that x is negative 5. So we know 2/3 of a second. Not 2/3 of a second. We know 2/3. X is 2/3. Sorry. Thinking about the yesterday's problems. 2/3. Okay, so now we got to figure out what are the dimensions. Well, x is my width, right? So I said my width is 2/3 of an inch. 2/3 of a meter, right? My width equals 2/3 of a meter. And that's okay to leave it as a fraction. You can turn it into a decimal if you want, but you can leave it as a fraction. And then the length is 3 times 2/3, right? Plus 13. You guys agree with that?
Yeah.
And when I do 3 times 2/3, what does that equal? 3 times 2/3, that's 3.
It's 2.
The 3's cross out, so it's just 2. 2 plus 13 is 15. So my length is 15 meters. So I know that this is 2/3, and this is 15. Isn't that cool? But by using quadratic equations and factoring using Gary's terrific trick, we were able to find the dimensions of that rectangle. Does that make sense? So let's look at it one more time, and since I'm only going to do one of them today, because I want to give you guys the homework because we have a shorter class.
Yeah.
So to review it again, do you guys understand how I got, when it says 13 meters more than 3 times its width?
That gets more
The
than
width is
13
x,
more than-
right? And then the 13 more than goes off to the right, 3 times the width, I put 3x. Once I've got that, I realize it says my area is 10 square meters, and area is length times width, right? So I did length times width equals 10. And then I multiplied it out, subtracted the 10, set it equal to 0, and then I factored it using Gary's terrific trick. Make sense? And then once I got the only positive one, the positive answer, that's the one that's the right answer. And then I give my final dimensions. Make sense?
It makes sense, it's just a lot, so it's kind of confusing because of how much it is.
It seems like a lot, but once you, the first step is just do this. Draw your rectangle,
I know, but
and
like,
do these.
all of
and then I agree, it does seem like a lot. But it's really sort of a natural progression. Does that make sense? I mean, you do that, and then you realize, oh, well, area is that times that, so you write it, equals 10. Then you realize you got to get rid of the parentheses, so you get rid of the parentheses, subtract 10 because you got to have to be equal to 0. And then you realize, oh, I'm ready to factor. And once you're factoring, you're
It's all
almost done.
easy stuff, but when it's put together, it just like,
I agree.
it's a lot
I agree.
to memorize.
How many
I agree.
problems are on homework, Gary?
Well, there's only 3 more word problems, and then a bunch of practicing finding the zeros.
Oh,
Okay? So it's not that hard. Okay, I'm going to just stop.